advanced composite materials in University of Auckland. Our group spent more than 10 years for a flame retardant and flame retardant polymer composite. So today I'd like to introduce Keratinous-based flame retardant. This is outline of my presentation. First of all, I'd like to introduce the basic knowledge about the combustion and how to measure the flammability. After then, I will focus on the keratinous-based flame retardant. Then finally, I will show you why we choose chicken feather as a host material of the flame retardant. The three elements of the combustion is heat, oxygen, and fuel. So to protect these three elements combined together is the technology of the key technology of the flame retardant. So this is the flame retardant we study. This is the intermittent flame retardant. When we expose a flame to the flame retardant, then the flame retardant immediately produces carbonaceous char, so it inhibit the contact of the air and fuel. For the flammability evaluation, we use several techniques. For the material analysis, we use TGA and DSC. And for flammability test, we're doing bench scale test and large scale test. So we usually perform cone calorimeter test and vertical burning test for the composite material. And for the final product, we are doing large scale tests such as the room corner test. So before I introduce the keratinous-based flame retardant, I will briefly introduce the method of the flammability test. For the vertical burning test, we usually prepare these rectangular specimen. After that, we expose 2 times of flame, each for 10 seconds. If the material is survive at the 2 times of flame exposure without the cotton fabric burning, then the material can achieve visual grade. That is the best grade. But the material can be completely burned, or the melted drift from the specimen to the cotton, maybe burn the cotton fabric. Then it depends on the flame and the glow time. We can grade V1, V2, or no grade, no rating. For the quantitative analysis, we use cone calorimeter. Cone calorimeter measure the oxygen concentration and gas flow. So with the basic data, we can get the value of time to ignition, peak heat release rate, and total heat release rate, smoke production rate. Then I will explain the retardant. The halogenated flame retardant is conventionally used, is still occupied about 1/3 of the market. However, the halogenated flame retardant is phased out these days, so metal hydroxide and phosphorus-based flame retardant is emerging now. Metal hydroxide is sustainable and it have low cost. However, to achieve the acceptable flame retardancy. For example, V0 grade for vertical burning test, it need about 50% of addition. And at that time, the strength drop is happen about 50%. So we studied the phosphorus-based flame retardant. Among the phosphorus-based flame retardant, incandescent flame retardant is popular these days because of the less toxicity and high performance. The incandescent flame retardant is composed of these three constituents: acid source, gluing agent, and char former. When we expose a flame, then the flame retardant make a carbonaceous liquid. After then, gluing agent expand the liquid. During that time, the acid source can be act as a catalyst. So it can make a carbonaceous char. So in our experiment, high performance and low cost, non-toxic process was focused. Various types of keratinous materials can be used for our experiment. We focus on fiber and feather. As you can see here, the fiber is composed of just a single strand. However, a feather is composed of various parts, such as shaft, lattice, and barb. So when we use the feather, the sorting process is necessary. The mechanical property of the feather is comparable with fiber. However, the tensile strength of the feather fiber is very different depending on the part. So I've already said that the sorting process is very important. However, when we think about the cost reduction of the product, then we have to consider the usage of the feather fiber, such as chicken feather. While the cost of the horse wool is around $2 per kg, but the most of the chicken feather usually go to the incineration or landfilling. So if we can use this feather fiber, then we can significantly decrease the cost. So due to the easiness of the handling, we first start with the wool fiber for the keratinous fiber-based flame retardant fabrication. This is our strategy. Apart from the mechanical property and the cost, the important reason we choose keratinous fiber as a host material of the flame retardant is the excellent fire resistance property. The keratinous fiber have an abundant amount of nitrogen, so that can be used as a gluing agent, and some amount of sulfur can be used as an acid source, and also hydrocarbons can be used as a char former. However, the flame retardancy of this material is not enough for the polymeric composite modification, so we add some amount of phosphate in the fiber. So in this technique, keratinous fiber is a container to hold the phosphate, and also this keratinous fiber can be a flame retardant on its own. So this technique have an advantage to control the constituents loading. This is the chemical treatment process. First, we treated phosphoric acid to the wool fiber. Then we can make phosphoric acid treated wool fiber. After then, we can treat reactive amine. In this experiment, we use ethylene diamine. So after the modification, the surface of the wool fiber was changed here to here. And this is the cross-section of the fiber. To check the existence of phosphorus inside of the fiber, we use EDS mapping technique. So as you can see, the phosphorus is uniformly distributed inside of the fiber. So after the treatment, the phosphorus content was increased 0 to 17%, but the carbon content was decreased 71 to 46%. This is the practical process of the flame retardant treatment. So when we treated the phosphoric acid to the wool fiber, the color of the fiber is a little bit changed to light red. But when we treated reactive amine, then the color was recovered like this. So using the flame retardant keratinous fiber, we produce the composite. Unlike pure polypropylene and only wool fiber modified polypropylene composite, these flame retardant keratinous fiber modified composite achieved B0 grade. It is comparable with the APP-PP. APP is the commercialized material that is ammonium polyphosphate. It is a typical material for intermittent flame retardant. So we can also achieve very similar flame retardancy. The similar heat release rate, peak heat release rate shows the similar flame retardancy. So in this context, we performed the cost analysis. After the cost analysis, we found that we achieved low cost compared to ammonium polyphosphate. However, there was some room for improvement because the price of the ethylene diamine and the post-wool fiber was quite expensive. So for the cost reduction, we choose chicken feather. This is the morphology of the chicken feather, chopped chicken feather. The most difficult thing to use the chicken feather as a reinforcement or filler to the composite is how we can give the uniformity to this particle. But in our experiment, we use strong acid and reactive amine. Sometimes that is alkali. So after the modification, the chicken feather was pulverized like this. We can achieve very fine particle. The mean particle size of this is around 70 micrometer. So using this particle, we prepared 5 types of flame retardant chicken feather with different molar ratio of phosphoric acid and ethylene diamine. So after the modification, the chemical structure was completely changed. Here is the untreated CFF, and this is the flame retardant chicken feathers. And the thermal property was completely changed. So using this, we prepared composite using melt mixing and the compression molding. Every composite show very similar flame retardant performance. However, when we compare the mechanical property, the composite with flame retardant chicken feather with lower phosphoric acid ethylene diamine molar ratio shows the higher tensile strength. Actually, after the modification, the modulus was improved compared with that of polypropylene. However, usually in the case of the when we use the intrinsic flame retardant, the strength is decreased. However, in our case, this one is higher than the commercialized APP modified polypropylene. So in this experiment, we found that this technique also useful for controlling the comparability between filler and matrix. So after the process simplification and replacing the host material from wool fiber to chicken feather, we achieved cost reduction. However, we are still using ethylene diamine, so there is a room to decrease the cost with a cheap reactive amine. So we prepared these two types of flame retardant chicken feather composite. FR CFF number 1 have ethylene diamine phosphate, and FR CFF number 2 have melamine phosphate. However, the flame retardancy of the melamine phosphate is a little bit lower than the ethylene diamine phosphate. We add some amount of APP. This is the commercialized material. So after preparing the flame retardant additive, when we compare the chemical structure and the thermal property, it was completely changed compared with the untreated chicken feather. And we also achieved very similar flame retardancy, except for FR CFF number 1 could not achieve any grade in the vertical burning test. However, the composite with melamine phosphate, that is FR CFF number 2, achieved best tensile strength compared than that of other composites. So we compare the relative price with this composite. So the replacing the wool fiber to the chicken feather, and also the process complication. And when we replacing the ethylene diamine phosphate and melamine phosphate to melamine phosphate, we can achieve about 30% of cost reduction. So we expect that this flame retardant can be useful for the waste recycling and the eco-friendly flame retardant fabrication. This is conclusion. Keratinous fiber and phosphorus compound combination is very effective for reducing the flammability of polypropylene. And chicken feather-based flame retardant provides synergistic effect, not only flame retardancy, but also mechanical property improvement. Chicken feather fiber melamine combination is significantly useful, not only to diminish the aversion from toxic process, but also to reduce the production cost. Thank you.